Hello everyone, my name is Piotr Wendykier, and today I will talk about import and export of tabular formats. I will start a brief introduction about the columnar data structure that is called tabular, and then describe our recent updates in CSV and TSV formats. Next, I will talk about new formats that will be introduced in the Wolfram Language 14.2, that is Parquet, Arrow dataset, ArrowIPC and ORC. And after that, I will give some updates about spreadsheet and statistical formats. And I will finish with a little preview of data connection object. So let's start from the columnar data structure. You probably have seen a very similar slide if you attended Rob Knapp's talk a few hours ago. So what do we have? We have a two-dimensional data set. This is also known as data frame, table, and structured data. Each category each column represents a variable, and each row usually represents a measurement. And usually each column has its specific type. So types are homogeneous along columns. These types could be categories, numbers, dates, strings, or Wolfram expressions. There is also yet another important property. Data elements can be missing, as shown in this date column here. So we call that tabular. We call this columnar data structure tabular in the Wolfram language. This is a new object coming in Wolfram language 12.2, 14.2. There were already 3 talks earlier today. I already mentioned Rob Knapp's talk, and there was also visualization, tabular visualization and tabular displays talk that just ended, I think, right before my talk. So let's start from creating a tabular object, and I'm going to create it from the data stored in a file, CSV file. So using import of a CSV with the import element called tabular, I get this tabular object. What you can do, again, I refer you to the previous talks for details, what you can do with this. I'm just briefly going to mention here that you can easily get type information for each column by calling column types property on that tabular object, and you get the association where you have keys being the column labels from this tabular, and the values are the types for each column. You can select columns, say I want to select only common name and number of trunks. This is basically tabular of the trees that are in the city of Champaign. And so say I'm only interested in these 2 columns. I'm selecting all rows, but only these 2 columns. And this is my output tabular. I can also very easily select rows. This is the basically span from the first 3 rows of a tabular object. It's returned also as tabular. So that was a quick overview of Tabular. Let me focus in the rest of this talk on the import and export side. So I'm going to start from the improvements in the CSV and TSV. So first of all, we improved column type inference. So this is a comparison of Wolfram Language 14.2 versus 14.1. So in 14.2, import of tabular element automatically parses these two columns from this file, tournament CSV, start date and end date, as a date type. And that's what it shows. So I'm importing the file as CSV file as tabular and selecting these two columns and asking for column types. And this is what I get. Start date is of this type, and end date is exactly the same type. To compare, in 14.1, you can import this CSV file as dataset, and what you get is a string, basically. We do not automatically parse these columns as dates. And there are various type inference improvements like that coming in version 14.2. So this is quite significant improvement performance. So to compare performance of new CSV and TSV import in 14.2, I decided to use a NYC yellow taxi trip dataset. It's almost 2 GB CSV file with more than 12 million rows and 19 columns. And here are the column types. So mostly integers or reals, but there are 2 columns that are of type date. And in this comparison, in this benchmark, in version 14.1, I used data import element for to getting the data, to measure the time needed to get the data. And in 14.2, it was a tabular import element. By the way, we are not changing the default import element in 14.2 for CSV and TSV. It's still going to stay data. So if you really want tabular coming from CSV file, you have to specify it explicitly. The default element will stay data, will be data. And here is the time difference. So less than 7 seconds import time in coming 14.2 versus 206 seconds previously. And export is similar, less than 34 seconds versus well, a long time to wait to export that to a CSV file in 14.1. You may ask why the difference, maybe not that significant, but still 7 versus 33. Most of the time that export needs to convert to convert that tabular to CSV is spent on converting these date columns. These 2 columns have to be converted to strings and then saved as CSV file. And well, that conversion takes time for the more than 12 million rows times 2, right? Because we have 2 columns. How exactly we are converting date to string, this will come in the next few slides. So let's move on. Header detection. You probably already noticed when I imported that Trees of Champagne file, it was already nicely showing the first row of the CSV file as the header. And there are CSV files that don't have any header, and this is the example. And then we introduce this virtual keys that basically the column keys property of Tabular returns none for them. It's probably going to stay like that in the 14.2 release. So this file, this Tabular does not have column keys because there were no headers, but this one is automatically recognized. Import just recognizes that it's probably the header and even treats it as a header for the Tabular object. However, there will be cases that import may interpret the first row or the header row incorrectly. That's why we have options, header lines and skip lines. So here is the one example. Here is only 2 columns, and both of these columns in this CSV file are of string type. So we cannot really distinguish between whether the first row should be a header or not, because they are all strings. We don't have any distinction between the types of the columns. So by default, we import this file, not recognizing the header, even though that was incorrect. So you can easily fix this by using header lines goes to 1 option. All right, missing elements detection, another new feature in import of CSV. Some elements can be missing in a CSV files, basically something like empty string or some strings that usually should be interpreted as missing, such as NA, null, and so on. And we recognize all of these cases by default, and notice all of these dashes here means that this particular element is missing. Here I'm just showing missing counts per column. So this is our list of missing values. All of these values by default are going to be interpreted as missing. You may not like it, but that's why we have the missing value pattern, and you can use list of strings, strict expression, or regular expression, and it will only use the value of that option to mark missing elements. So say in this example, I'm saying that all negative numbers and empty strings should be considered missing. And there was an empty negative number here and here. Notice they are now missing. But on the other hand, null and NA are not missing. They are interpreted as strings. That also changes the type of these columns. They have to remain strings, and they were, numeric columns previously. Okay, there will be some backward incompatible changes because we are using completely different backend for import and export of CSV. Hopefully, there won't be really visible in most of the workflows. Let me mention few of the backward incompatible changes. So the default value of the currency tokens option is going to be equal none in 14.2. It was it was a list of some tokens like that in 14.1. So you can basically specify this explicitly to get the previous behavior if you really want the currency tokens to be recognized. Another backward compatible change, real numbers with 0 factorial part will be stored in a file as an integer. So you see 1 point and 2 point are actually converted to 1, 2 in the file. Another change that is incompatible are the quoting characters around empty strings. However, you can get back the previous behavior using this new import options, include quoting character goes to none. And I mentioned the export of dates column. So in 14.2, we will be exporting date columns using date string function with this ISO standard way of saving the dates. So this is what you get. These are the strings generated from these data objects. And when you import it back, you get already it's basically round tripping. You export the date column, you get it stored in such strings, and you import it back, you get exactly the same date format. So that was all about CSV that I wanted to tell today. Let's move on to other formats. So quick updates about spreadsheet and statistical formats. So these are the formats that we call spreadsheet formats. So mostly the most popular are Excel and XLSX. And this is the list of statistical formats that we support. All of these formats will have 1 or 2 new import elements. I mean, first, all of them will have tabular import element. Again, we're not changing the defaults for them, but we're just adding new import elements. So Excel, you can import Excel data as tabular. But spreadsheet formats usually have more than 1 sheet. So that's why we also add tabular association elements, and you get the association when you have the name of the sheet goes to the tabular. So there we have five sheets in this file, and that's what you get when you ask for tabular association. There is also automatic header detection in the spreadsheet format. So this is the example. I'm asking for tabular just asking for the first sheet from this file, and it automatically recognizes that city, country, and population row should be treated as header. But you can also use header lines to adjust if something goes wrong with the detection. Possible issues. I want to point out one issue here. Notice when we import, I think this is the most visible here. So let's look at this first sheet from this Wind XLS file. This batch E here in the corner means that all of these columns are of type inert expression. We probably don't want them. This should be actually real 64 numbers, and this should be a date. What's going on? When you scroll all the way down, you notice there is one empty column, which probably is not really the problem. The problem is this one, that this is a string here that it cannot be converted to date. So if I skip the last 2 columns, and by skipping, I can just specify partial access here. So this is just take all the rows. Sorry, I mean rows, not columns. We're going to skip rows. So we're skipping the last 2 rows by specifying this syntax here, and then we get a date and real 64 as expected. We can also export tabular to Excel and other formats that we support for like statistical formats. We also support export to these formats, and exporting tabular also works. All right, I don't have much time left, so quickly about new formats. Parquet, ArrowIPC, and ORC. These are the new binary formats that are really designed for storing tabular data, and they store them efficiently and support various compression schemes. So these are the formats really recommended for storing large tabular data, and not CSV, even though we know that CSV is a very popular format. It's better to import it as CSV, but when you get your final tabular object that you want to share with somebody, export it to one of these formats. So what are the advantages? I mean, they are not stored as strings. These are binary formats, so they do support all of the types, column types that we have in tabular. Well, ArrowIPC and Parquet support most of the types. Some column types are not supported by ORC, but I mean, we do our best to convert to something that is reasonable. So notice here, I was storing images. This is the column type of tabular column of type expression, inner expression. As I mentioned previously, we can store any Wolfram language expression, and the way to store it in a file, we use binary serialize to serialize that expression and store it as the binary format in ArrowIPC, Parquet, or ORC. And when we import it back, we use binary deserialize. And that's why it's transparent. You see, you have the expressions, you export it to the file, import it back in Wolfram language, and you get the expression back automatically. Compression methods. By default, we optimize for speed in export, so by default, we don't use compression, but you can use various compression schemes in all of these three formats, and this is the summary. You can go from almost 2 gigabytes to 30 to 300 megabytes and so on. But that takes more time. Sometimes it takes much longer, 35 seconds versus 5 seconds uncompressed, depending on the compression scheme. Performance comparison. So I'm comparing CSV. You saw these results before using the same data set as in my CSV slides for performance comparison. But notice that these binary formats are much quicker, both import and export. So again, strongly encouraged to use these formats instead of exporting to CSV. There is one more new format coming. It's called Arrow dataset. Very quickly, this is a storage format for multi-file datasets. So it's basically a directory of files with one of the following formats, and all of these formats are described before. And usually it's a partition dataset. And that means that we have one or more columns that are used for partitioning, and the directory structure with subdirectory names hold the information about which subset of the data is stored in that directory. So let's take our city of Champaign tabular. This is more than 26,000 rows. And let's generate such such arrow data set, you have to use the option split columns. You have to pick at least one columns that you're going to be using for splitting. So I'm choosing number of trunks for that, and when I export, this is what I get. So this is the directory. My output dir is a directory that I just created, and here are the directory names and then the content of that directory. So single Parquet file and the file size of that file. So what happens when I import just the first file, the first Parquet file? I get a tabular, right? But notice the dimensions. I get only, this is only 5,000 and only 5 columns. So this is just a subset of my original data set. And I'm missing one column, the column that I use for splitting. So to get my original tabular dataset back, I want to import the whole directory as arrow dataset and use a valid partitioning schema. And that's when I'm getting exactly the same what I started from, the same dimensions. And finally, data connection object. So we are introducing something new that can be used together with import. It's an object to a remote resource, and remote resource could be something like Amazon S3 storage, Azure Blob storage, Dropbox, and so on. You can use it for creating a notebook with. You create a notebook, store such data connection object. You could provide authentication together with that inside that data connection object, or actually, if you don't, then you get the dialog and that will ask you for credentials. But then you can easily share it with the colleagues, and you can work on the same data. So we're hiding quite the details of authentication and all of the connection properties needed behind this simple data connection object. There will be a way to control refresh. How do you refresh the data, local caches, and so on. We are going to release a few data connections in 14.2, but the next release we really hope to get much more connections. And as I mentioned, it will be integrated with imports. So quickly, let's look at how it would work. So you create such data connection object specifying all the properties. This is the Azure Blob storage, and we are pointing to a Parquet file. So you can ask for the file format of this data connection object, or you can actually import Tabular, because it will recognize that this is pointing to a Parquet file, and it just imports it as a regular Parquet file, but with the default element being Tabular. So that's why you're getting Tabular. And finally, this is just one example that you can do basically online analytics. So this is basically a remote file that can change, but then every time you evaluate this, you may get different results depending on the content of this file. All right, so that's all the slides that I prepared. Let's see if there is something I can answer in the last minute or so. All right. Well, thanks, Sean, for helping me with this. There were a few questions, but I'm hoping that most of them have been already answered. So let's see. Very large. I have very large data sets. There is a max size where I have to adjust things like stack, heap size, etc. Well, if you have enough memory, then you don't need to adjust anything. Basically, that's if it fits into your memory, then that's what's going to happen. I mean, it should be as efficient as possible, and we don't have any limitations. Can I download all the linked tables from the remote Postgres schema into a tabular? I hope the answer is yes, and you get this out of core tabular. I refer you to Rob Knapp's presentation. He was showing the example how to do this. Exporting tabular objects to MX, WDX, and WXF. I hope so. Well, we have to test that, but that should definitely be possible. But again, not really recommended though. I would really recommend using the dedicated formats like Parquet and ArrowIPC. I think I'm going over time, so I probably finish. I'm going to have office hours in 30 minutes, Sound and Vision office hours. Feel free to join, and we can discuss further. Thank you very much.